Welcome to Statistics. My name is Dr. Twane. In this class, we are going to carry out the one-way analysis of variance. Now, the one-way analysis of variance is also known as one-way classification, or we'll say the one-factor analysis or one-factor classification. Now, the model associated with the one-way analysis of variance is given as, we'll say, y sub ij is equal to mu plus tau I plus epsilon ij. As I goes from 1 to t, where t is our number of treatments, and j goes from 1 to r, where r will be our number of rows. Because in this case, our concentration will be on the number of treatments, but we also have certain number of rows. Now, the implication of this model is that our y sub ij are our individual values. And mu is the overall mean. The overall mean is our mu. Then tau I is our treatment effect. Epsilon ij is the error associated with each of these observations. Okay, having said that, the problem we have to solve in this class is to ascertain the effectiveness of poultry fields. 4 types of fields were given to birds in a certain poultry farm, and the weights of the birds taken after 8 weeks are tabulated below. Conduct the one-way Anova, that's the one-way analysis of variance, and test the significance or test the hypothesis at 0.05 level of significance. Now, the information we have is that our F1, these are the weights of the birds that were given feed 1. These are the weights of the birds that were given feed 2. These are the weights of the birds that were given feed 3. And then these are also the weights of the birds that were given feed 4. So to conduct the one-way analysis of variance, there are very key things we are expected to do. One is to calculate what we call the correction factor. So I call it a CF. Now, after calculating our correction factor, we'll also calculate what we call sum of square total. Now, after the sum of square total, we're going to calculate what we call sum of square between group. And then we'll also calculate sum of square within group. Okay, now after that, we are going to calculate our various degrees of freedom. And then after which we'll calculate our mean sum of square between group, mean sum of square within group, and then we'll calculate what we call the F-curve. Okay, so these are the basic things we are going to do in the one-way analysis of variance. Now, based on the information we are given, let us start. Now, to calculate our correction factor, the formula is given as t squared all over tr, which is equal to, now, what is our t? Our t is the summation of all these values. So it will be easier if we just say from here that our summation of f1 is equal to, if we sum these values, what do we have? 13. Now our summation of f2 is equal to, if we sum these values, what do we have? 19. Now our summation of f3 is equal to 13. And then our summation of f4 is equal to, if we sum these values, what do we have? 20. So if we sum 13, 19, 13, and 20, it will be equal to 65. Okay. So which means that our correction factor is equal to 65 square all over our T is the number of treatments, which is 1, 2, 3, 4. So we have 4 into our arrow is the number of rows, and we have 1, 2, 3, 4, 5 rows. So which is 5, and that will be equal to. So what's the square of 65? 4, 2, 2, 5. All over 4 times 5 is 20. So if we divide 4225 by 20, it will be equal to 211.25. Okay, thank you. Now the next thing we have to calculate is our sum of square total. Now the formula for calculating our sum of square total is equal to, we'll say, double summation of y sub ij square as I goes from 1 to t, and then j goes from 1 to r, minus our t square all over t r, which is our correction factor. Or, so there's also another formula which is giving us summation of f1 square, which is what we have there, plus summation of f2 square, plus summation of f3 square, plus summation of f4 square. All right? So minus our t square all over t r. So if we are to use this formula, I think it will be more easier than this. Okay, so now for us to use that formula, it means that we are going to create a column and call it f1 square, so that when we sum it, we'll have the value for summation x1 square. We also create another column and call it f2 square. So the sum of that will also be the value for summation s2 square. We are going to do the same thing for f3 and then also for f4. So our f1 square will be 2 square, 3 square, 4 square, 2 square, and then 2 square, 4. 4 square again, 16. 4 square, 16. And then 3.5 square is 12.25. So the next thing will be to get the summation of this. So the summation of our f1 square will be equal to 37. Now again, the summation of our f2 square will be equal to 72.5. If we sum our f3 square, it will be equal to 34.5. And then if we sum our f4 square, it will be equal to 80.5. So then the sum of all of this will be equal to 224.5. So, which means that here our sum of square total will be equal to, our f1 square is 37, our f2 square is 72.5, our f3 square is 34.5, and then our f4 square is 80.5. So we have all of that minus our correction factor is already calculated as 211.25. All right. Okay, so this will be equal to, if we sum the whole of this, which is what we've already done here, it will be 224.5 minus our correction factor, which is 211.25. So if we subtract 224.5, this from this, it will be equal to, we have 13.25. Okay, so our sum of square total is equal to 13.25. Okay, now the next thing will be to calculate uh, between group sum of square. So sum of square between group is given as 1 over arrow summation of yi square as I goes from 1 to t minus our correction factor, which is t square all over t arrow. Okay, or summation of yi, which is what we have there, our f1 all square all over arrow plus summation of f2 all square all over arrow plus summation of f3 all square all over arrow plus summation of f4 all square all over arrow minus our correction factor, which is t square over t arrow. So if we are using that particular formula, it will mean that our between group sum of square will be equal to the summation of f1 is 13. So we'll have 13 square all over arrow, the number of rows is 5. So all over 5 plus summation of f2 is 19. So we'll have 19 square all over 5 plus the summation of f3 is 13. So we'll have 13, but it's square. So 13 square all over. Our arrow is 5 plus the summation of f4 is 20. So we'll have 20, but it is square too. So 20 square all over 5. All of that minus our correction factor is 211.25. And so it will mean that the square, we are going to take the square of 13. So 13 square is 169 all over 5. Again, we are going to take the square of 19. So it will be 361 all over 5 plus the square of 13 again. We already have that here. 169 all over 5 plus 20 square will be 400 all over 5. All of that minus our correction factor, which is 211.25. Okay, so which will be equal to, now if you take 169 divided by 5, 3.8 plus 361 divided by 5, 77.2. Now 169 divided by 5, 3.8, and then 400 divided by 5 will be 80. Now all of that minus 211.25. So this will be equal to, if we sum 3.8, 77.2, 3.8, and 80, what will it give us? 219.8 minus our correction factor, which is 211.25. So that will be equal to 8.55. So that means that our sum of square between group is equal to what? 8.55. Okay. So the next thing to calculate will be, from what we outlined earlier, will be sum of square within group. Note that sum of square total is equal to sum of square between group plus sum of square within group. So this will imply that our sum of square within group will be equal to, now this moving to this other side, will have sum of square total minus sum of square between group. So that becomes our formula for a sum of square within group. However, we have been able to calculate sum of square total. So it will therefore mean that our sum of square within group will be equal to, now sum of square total we calculated as 13.25. 13.25 minus our sum of square between group, which we calculated as 8.55. 8.55. So if we subtract that, it will mean that our sum of square within group will be equal to 4.7. Now the next thing we have to do is to calculate our degrees of freedom. So we'll have um, between group degree of freedom is the formula is given as t minus 1. Our t is number of treatment, which is equal to 4. So we'll have 4 minus 1, which is equal to 3. Now we also have within group degree of freedom, which is given as t arrow minus t, and that will be equal to, we already have the value for t arrow somewhere. T is 4, arrow is 5, so 4 times 5 is 20 minus our t is 4. So 20 minus 4 will be equal to 16. Okay, now our total degree of freedom is given as t arrow minus 1. Total is also given as between group degree of freedom plus within group degree of freedom, which will be 3 plus 16, and that will be 19. But if we are using this, it's also our t arrow is 20. So we'll have 20 minus 1, which is also that same 19. So having calculated our degrees of freedom, the next thing will be to calculate our mean sum of square between group. And that is given as sum of square between group all over between group degree of freedom. Okay, we already calculated our sum of square between group, and we got 8.55. That's it. All over our between group degree of freedom is 3. So this is 3. So 8.55 divided by 3 is equal to what? 2.85. Okay, so the next thing is mean sum of square within group, which will be equal to sum of square within group all over within group degree of freedom. Now our sum of square within group we calculated as what? 4.7. So we'll have 4.7 all over. Now within group degree of freedom, our within group degree of freedom we calculated as 16. So we have 4.7 divided by 16. 4.7 divided by 16. 0.294. Okay, so that will be 0.294. The next thing we have to calculate is our F car, and our F car is giving us mean sum of square between group all over mean sum of square within group. So which will be equal to our mean sum of square between group is calculated as 2.85. Right? And also mean sum of square within group is calculated as 0.294. So 2.85 divided by 0.294 is equal to 9.70. Okay, let's say that's 9.70. So that's our F car. Now the next thing is to put okay, I think the next thing will be source of okay, having calculated this, the next thing would be to okay, after calculating our F value, we'll have to give the summary table which summarizes all of this result. So we'll start with what I want to call our sources of variation. Sources of variation. Then, after the sources of variation, we'll have what we call our sum of square. Our SS is sum of square. And then, after the sum of square, our degree of freedom. After the degree of freedom, then we also have a column for our main sum of square, and then before our F car. So what are the sources of our variation? The first is between groups. Then we also have within groups. And then our total source of variation. Now, the sum of square between groups. Look at between group sum of square. We calculated as 8.55. Now, our within group sum of square. Within group sum of square, we calculated as 4.7. Call it 70. So the total, which is the same thing as summing this and this, we calculated the total sum of square as 13.25. I'm sure if you add this and this, it will also give you 13.25. Now the degree of freedom. Between group degree of freedom, we calculated as 3. Within group degree of freedom, we calculated as 16. And then the total degree of freedom we calculated as 19. I'm sure if you add 3 and 16, you'll see that it's also 19. Now the mean sum of square. Mean sum of square between group we calculated as 2.85. So we'll have here 2.85. And then mean sum of square within group we calculated as 0.294. Okay, so our F cal, which we calculated as 9.70. So if you divide this by this, I'm sure you're going to get 9.70. So note that we initially told you that the model for the one-way analysis of variance is giving us y sub ij is equal to mu plus tau I plus epsilon ij. And the tau I is our treatment effect. So the non-hypothesis HO will be, we can say treatment effects do not significantly differ. So if we take that as our non-hypothesis, it means that our alternate hypothesis we're saying treatment effect significantly differ. So we already calculated our F cal as 9.70. So our F critical, let's put it as this, F crit, we are saying 0.05 level of significance. The degrees of freedom are, this is N1 and this is N2. We have 3 under 16. So check your statistical table, F 0.05, 3 under 16. And what do you have? That is equal to 3.24. Okay. So if we've done that, then you can see that the calculated F, which is 9.7, is greater than the tabulated F, which is 3.2. So because the calculated is greater than tabulated, we are going to do what? Reject the none. So when you reject HO, you are invariably saying that treatment effect differ.